someone needs to mute it.
Might be posted.
I think that's right.
That's neat.
I just muted the microphone.
Silence. Thing now.
Yeah. Okay. You can unmute the microphone now if you want. Just as long as like the sound's not coming out, you should be good. So if you click back on the little red microphone icon.
This one.
Yep. There you go. There you go.
And now.
Yeah, I just need to mute the speakers, but now I think you should be all set. But there you go. So it's gonna flip to you two each time one of you. There you go. So it's gonna flip to you two each time one of you.
Hello.
So yeah. So Andrew, you're seeing it switch. Yeah. So Andrew, you're seeing it switch back and forth. You're not.
Yeah.
But if I switch back,
I don't know. I don't see it.
No.
Oh, yeah. But you manually do it, right?
Yeah, I just manually did it.
But all this is being recorded.
It is.
For posterity.
Yep.
This is our first office hour.
Yes, this is our first office hour. So I'm here, Andrew Duffy, and Mark Green is also here.
I'm not sure why it's not moving to yourself there, so.
And the next one always here.
Hello.
I think we're all set. I'll give you someone to come up and ask us questions.
Awesome. If you also use your speakers, it'll keep the echo effect from happening again. So it's still going to hear your, still going to pick up your microphone, but there you go. So just make sure your speakers are muted, so like the echo doesn't happen.
No one's actually going to
So how can they
Tell us
our
to
speakers
say
are
anything.
muted? How do we speak?
So your microphone's still picking up your voice.
So this should also be recorded as a step.
Yeah.
My ignorance of this process is being
It's fine. It's all
demonstrated, which I'm fine.
Yeah, just as long as like the actual speakers are muted, you're fine. Normally, I would tell you guys to use headphones like this, but
Yeah, I have. I'll bring that.
So there's two viewers here. Hello. Two viewers.
Are you?
there's one.
yeah, you just are.
And it flips when I talk. You can hear us.
Yeah.
No,
If you want to see yourself, see him, you can click on one of the two.
no, I saw what you did. You just. So if there's going to be other people, they should show up on the list here.
No, actually. So you two are the only actual participants in this. Everyone else that's going to the office hours and viewing the So they're kind of like, imagine people are standing up and one else is looking at
Right.
it.
So maybe with you, Andrew, and myself,
Yeah.
trying to respond to their questions.
And Andrew has the Q&A up. You see on the well, either way, Andrew can see the questions that people put them in, so you guys should be good in that kind This is a different one that's just a chat between you and Andrew. It's only with participants in the actual hangout. The Q&A app for some reason isn't showing up on the I think it's because Andrew's one set that up, so it's only going to show up on his. So just so you know, Andrew, you're the only one who sees the Q&A.
I'm the only one.
Yeah, because you do have the hangout, so the detail I forgot.
All right. So far, nobody's asked us questions.
Yeah.
Folks, feel free to ask us questions.
Yeah, so if you check the discussion forum and answer any questions that you saw in there before.
Yeah.
Okay, you guys good to go, you think, or want to stick around for a while?
If I type here, Andrew, will see you what I type.
Yeah. Yep, so it popped up.
It did? Oh.
That's true. But I won't see.
I was expecting to see a question over here.
So
Yeah, he didn't type in a question, he just posted a chat to you.
And how would I pose a question? Yes,
Yeah, you can't. You can't see him as like a student.
and I can't see the questions.
Nope, only you can see that right now. Set that up. I'll sign in on the different computers.
Oh, so I can send them in that one,
Yep.
and then I can see the questions. So,
It's obvious to the participants how to pose questions.
It should be. There's but there's like an area when you first sign on that has the questions area.
so if I just student view,
so that's just the link to the page that we posted there. I'm actually about to pull up the.
There's a lot of echo. Can you rectify this problem, please?
There's a lot of echo.
There's a lot of echo. Rectify this problem,
Yeah, I think it's just because each person links to each other, and like when you talk, you can go into this microphone too. If you want to mute it, I have to start talking.
I'm going to see if that a student said there's a lot of echo.
Yeah.
You can see that.
How do I answer the question?
So you did just
I just did. Okay.
just talking.
So just talking. Okay, good. Obviously, you can see that this is the first time we're doing this. So Mark Riemann is here helping me out, as well as Vanessa Ruano, and Mark and I were sitting right next to each other with our two computers open. So Mark is now sitting a little bit further away. So hopefully that will address the echo problem. So let us know if it doesn't. Let us know if you have other questions as well. Okay, so we're pretty much just waiting for everybody to ask us questions. So feel free to fire your questions in. Hopefully you can see how to do that. Should be able to type them in somewhere. How do they add a question? Because I'm on the Hangout myself and I can't figure it out.
If you're on the student view, you see at the top the little set of squares.
The set of squares.
Yep. And Q&A.
Ah. Okay.
So if you want to address a specific question, you can just click on your view. If you click on select, the students will then see you're answering that specific question.
Yeah. Okay, so when you guys are online, there's a set of 9 squares, a little icon near the top, set of 9 squares. If you click on that, you should be able to click on Q&A, question and answer, and then you'll see the questions, and you should be able to add your own question. Okay, so looks like we have a question. I was just wondering what that would it be possible for me to give 2 APs this year? I plan on giving AP Physics 1 and also AP Physics C optics. So I'm not sure I fully understand what you're asking. Is it possible for you to do both tests, for instance? Is that what you're asking? We can check in with our experienced physics teacher, Mr. Greenman. What do you think, Mr. Greenman? Can you take 2 physics AP tests in the same year?
At the end of the course?
Yeah.
Yeah, we'll have 2 practice AP
But
tests.
what can they take physics, AP Physics 1 and AP Physics
They're 2 separate
C?
tests.
And they can take 2 separate tests?
They can. I mean,
It's
yes.
possible.
Yes, they have to sign up for the 2
Yep, if you
tests.
sign up for 2, you can
Absolutely.
take 2. So I'm not sure if that exactly is your question, but if that is the question, you can take more than 1.
Although this course will not prepare them for the
Yes, of
obviously,
course,
for the
our course
second
will
test.
prepare you for AP Physics 1, not AP Physics C optics, because there's no optics in our course. So I should have selected that from the list, shouldn't I?
Yeah, if you get any more, if you want to answer physics one, just click on select.
Okay. If that wasn't exactly your question, then try that again. Question. I'm just looking at the course discussion forum to see if anybody's posted anything there. And it doesn't look there like there's any questions there either. Okay.
Also take a look at the the other post from before and see if there's anything.
Yep.
in this.
Okay, I'm glad we answered the correct question earlier. That's good. So, good luck with your two different APs. Okay, so here's a good question. How will this course go about using the labs and student grading? So we really have two different aspects of the course that we're doing with labs. So one is just sort of the online labs that are built into the course itself. Some of those use simulations, for instance, and some use the direct measurement videos. And so there's no online grading for, there's no student grading for those. It's all graded by the edX system. And then separately, we have what we're planning on, I think, is 5 student grading activities, one of which is in Module 1. You've probably seen that one in Module 1. There'll be another 4 throughout the course, and I believe those count for, the student-graded ones count for 10% of your course grade, and the labs are something like 25%. And our goal there is really to address the issue of the AP Physics 1 test you're supposed to have 25% lab hands-on content with labs, which is hard to do in an online setting, so this is our idea for that. And plus, there's a lot of open-ended questions at the end of the AP Physics 1 test. And so these student-graded exercises are really a lot more open-ended for you to just explain your own thinking. And you'll have to do that on the AP Physics test itself. Okay, so that's how that's our thinking on those two components of the course. Okay, so Mahmoud here is fired in this question. I've been grappling with the tangent 0 seconds exercise. Still can't fathom what basis the orange line is a more valid line than the red line, for example. Additionally, from the way I can see it, it intercepts the curve on more than one point. Okay, so one thing that I can try and do is look at that in our course, if I can find it quickly, and try and draw it. Or draw a reasonable facsimile of it. So let me just search for it for a minute in our course, and then we'll try and address that question. So where am I now? There we go. Okay, anybody know where these tangent line things are? Let's see if I can find it quickly. There. Okay, I'm looking at average versus instantaneous velocity, and we have some tangent line things there, and I will find the one that you're talking about. Okay. Okay, so tangent at 0 seconds. So we've got the data, which is in blue. So I'm going to try and sketch this on our screen, which is behind me. So I don't know if you'll be able to see this on the screen, but I'm going to do my best at sketching this graph. Okay, so the data itself just starts at 0. It starts up steeply and then kind of starts to level off. And there is an orange line on there, which really starts heading off in the same direction as that blue line. Okay? So I'll draw that. Okay, I don't know if it's easy to see there. Let me go look at the Hangout for a second. Oh, and it's backwards. That's really cool. Okay, so I should have drawn things backwards and written backwards too, I guess. But the basic idea is that you have your data there, and the slope of the data has to match the slope of the tangent line at the area that you're interested in, which is right there at t equals 0. So the issue with the red line is that it's simply too steep, okay, where the orange one really does match the steepness of the data line very well, right there at t equals 0. So that's why you really want that orange one, not the red one. The red one's just too steep, and the other ones are basically not steep enough. Okay. Now, there's the issue of the orange one being on top of the blue one for quite a while. And what we've done there is we just made the data line very, very wide, just so you can really see it easily. And then the orange one just sort of follows that blue one for a while. But that's really because of the thickness of the line. We just drawn that blue one just so very thick. If we drawn it kind of thinner, then it wouldn't have that problem. Anything you want to add to that, Mark? No. Okay. That's interesting that the picture comes out backwards.
I know.
Okay.
Well, we can see it normally, so it just looks backwards to
Oh,
me.
it looks backwards to me.
Yeah.
That's right. It looks. If you're looking at this, it looks fine. Oh, that's good. It's only backwards to me.
Exactly.
Okay, thanks. Sorry for that confusion. Okay, I guess I should leave that up there. Okay, I hope that is somewhat helpful to answering that question. Feel free to fire in with some other ones. Okay, I just added some notations to the graph there. I also have the green line. Green line is really not steep enough, doesn't match the data. The red line is too steep, and then we have the orange one, which is sort of the Goldilocks one. It's the one that's just right. And as Mark points out, this is at time equals 0.
I can see what the orange line does look like. That's
Yeah. Right. Very true. Uh-huh. Okay, so feel free to fire in other questions if you have any. Mark, did your comments show up on the Hangout or not?
He's still muted, so.
I did not.
Okay. Oh, let me just repeat what Mark said, which he said he could understand the confusion with the graph because it does look like, just based on the drawing, the orange line cuts through the blue line at a couple of different places. But again, that's really because of how thick we drew that blue one. So it's more of a drawing issue. So. Yeah, and so we're looking for a tangent. The issue is that the slope of the tangent at the point you're interested in, t equals 0 in that case, matches the slope of the data line. And Mahmoud says, let me select that one again. So Mahmoud says, my point is the line you draw as the orange line seems like it intercepts the curve on some point beyond 0. And we would agree with that. You're right about that. It's not a perfectly drawn situation. So I would say the problem with the red line is just it doesn't really meet the data line appropriately at t equals 0. It's just way too steep. Where the blue one really has the right slope. And it's just because of the thickness of those lines that it follows it along and seems to cut that line at a couple of different spots. So you're right. It's not a perfect drawing. And Mark is asking whether you have a conceptual question about the tangent. And our apologies for the drawing issue there. Okay, so once again, if you're just joining us, I'm here at Boston University with Mark Greenman, very experienced physics teacher, and Vanessa Ruano, who's helping us out with the technical issues. And so our very first office hour, we've tried to address a couple of questions, but if you have other questions, feel free to fire away. Again, you should see an icon near the top of your screen with 9 little dots arranged in a 3x3 row. If you click on that, you bring up Q&A, and you can then open your question and answer sidebar, and you can post a new question if you do that. So. Okay, so Mahmoud is responding. It's just that getting the question wrong created a lot of confusion. Other than that, I was breezing my way through the other tangent line exercises even those I had to draw myself. Well, that's good to hear. I'm glad to hear that you were doing so well on the other ones. And again, our apologies for the drawing issues with that first one. So one thing I can say is just to give you an update about what's going to happen with the course. We typically release a module every week, but the first module we set out as a 2-week module. So the second module comes out. Usually it would come out on a Monday, but it's going to come out next Tuesday because Monday is a holiday here in the United States, the Martin Luther King Jr. holiday. So you can look forward to Module 2 coming out at 2 p.m. Eastern, right? 2 p.m. Eastern, which I believe is 1700 hours Universal Time. Okay, here's another question. Is relative motion applicable in a 3D plane? For example, taking the case of relative velocities, asteroids in space. And absolutely, yeah, we've really addressed it in a one-dimensional situation in Module 1, but it definitely applies in both 2 dimensions and in 3 dimensions. So there's some great 2-dimensional situations that we often do, such as a boat crossing a river, and then the current in the river is kind of dragging the boat downstream as the boat goes across. So you talk about the velocity of the boat with respect to the water, the velocity of the water with respect to the shore, the velocity of the boat with respect to the shore. Another similar 2D situation is one where you've got an airplane flying and the wind is blowing. Then you get the plane, its velocity with respect to the air's velocity with respect to the ground, and then the airplane's velocity with respect to the ground. So that's a good extension into 2 dimensions. And anything you can do in 1D or 2D, you can definitely extend to 3 dimensions. So it's a good question. Okay, so Mahmoud has another question here. It says, one other question. I understand the acceleration is a vector, which pretty much means that its direction counts. And that's exactly right. Anything that is a vector, you have to worry about both the magnitude and the direction. I've also learned that the gravitational acceleration is in the negative direction, which means it should be negative. Okay, so now that I would say, well, sometimes, you know, it's, first of all, the gravitational acceleration near the surface of the planet Earth is definitely down. But you get to decide whether up is positive or down is positive. And if I simply take a ball and I just drop it, okay, so I hold the ball in my hand. In fact, let me just hold something. Here's my keys. Okay, so I'm going to hold my keys here, and I'm just going to let go. So they simply fall down. So they never go up, they always go down. So in that case, I might say, let me just make down positive. Then the initial velocity is 0, the final velocity just before it hits the ground is positive, the acceleration is positive, the displacement is positive. So in that case, you could make down the positive direction. And then your acceleration, which is due to gravity, would also be positive. So whether it's positive or negative, actually is a choice that you make in terms of which way you make the positive direction in your coordinate system. Okay, so it doesn't always have to be negative is down. You can certainly decide to make positive down if you like. Okay, so Mahmoud goes on to say, let me keep going with that. So Mahmoud goes on to say, then why gravitational acceleration is written as 9.807 without the negative sign? Okay, so that's really why. So we're really looking for the magnitude of it there, and the direction is really, again, up to you. You can decide that up is positive. You can decide that down is positive. You don't have to always pick up is positive. And if you're writing that as 9.807, that's definitely that question where we asked you to state the gravitational acceleration to 4 significant digits. So that's where that 9.807 came from. Okay, so I hope that helps in that case. It's really a choice, that choice of positive direction, that determines whether the acceleration due to gravity is positive or negative. But we can all agree that it's definitely in the downward direction toward the center of the Earth. Any other questions that anybody would like to have addressed? And we're now about halfway through our time. So we start at 12 o'clock Eastern and we'll end around 1 o'clock Eastern time. That's the time it is here in Boston, Massachusetts. And just checking the online course forum, but nobody has posted any questions there yet either. So one thing I could do is talk about that situation of two-dimensional relative velocity. Let's get a little bit ahead of ourselves in the course, but somebody did ask about going to 3D, so at least I'll go to 2D. So I'll just sketch a simple situation of a boat trying to cross a river. Okay, so let me draw that. Okay, so there's our river. It's got a current going from left to right. And let's say we have a boat trying to cross this. And if we happen to point our boat, give it a velocity with respect to the water, which is directly across, well, we're not actually going to go directly across. Okay, so I've drawn a little vector there which says, let me see if you can see that any better. Oh, there it is there. Okay, you get the velocity of the boat with respect to the water. Pointed your boat directly across, but the current in the river is going to carry you downstream. So we draw on the velocity vector, which represents the water's velocity with respect to the shore. If we say, 2 meters per second, that's how fast the water's going itself. And so your net velocity, your velocity with respect to the shore, will be the vector is sum of those two, which is this one. Okay, so there we've got our situation, two-dimensional situation of a boat crossing a river, and the velocity of the velocity vector representing the velocity of the boat with respect to the shore, that's VBS, is the velocity of the boat with respect to the water added as a vector to the velocity of the water with respect to the shore. Okay, so there's a two-dimensional relative velocity situation. Let's see if we make that really big one time. So pick this up and, well, it's not bad. Okay, feel free to fire away with other questions. Mark or Vanessa, or anything I should be talking about? Okay. So we currently have 5 viewers listed, of which 3 of which might be us. Is that right? So there's right two real students out there. So again, if you're trying to figure out how to ask questions, you can look for an icon which is 9 dots in a 3x3 array at the top of your screen. Oh, Vanessa's got to go. Thanks, Vanessa.
When you're done, just on your screen for the stop broadcast.
Yes, I will try and remember to hit stop broadcast when I'm done, so you don't broadcast forever. Okay, anyway, there's that array of 9 dots in a 3x3 array there. If you hit that, you'll get the question and answer feature you can click on, and then as a sidebar, you will be able to type in some questions. And
You guys later.
see ya. Bye, Vanessa. So feel free to let us know how you think the course has been going so far. You know, what you've liked, what you haven't liked, what you think we could be doing better. You know, a lot of what you see in Module 1 we're going to try and keep doing as we go forward. But if you have ideas for things we can do better, we can certainly try and put those in for later modules. So we've got, again, Module 2 coming out next week. That'll happen on Tuesday. That'll be on just a basic introduction to forces. Then we get into two-dimensional motion with Module 3. That'll be the following week. So that'll be, let's see, the 26th. That'll come out. And then the first Monday in February, we'll have Module 4, which is back to forces. We sort of look at forces twice in Module 2, and then we bring in friction and do forces in 2 dimensions in Module 4. Okay, and then we get into circular motion, Module 5, as well as gravitation. That's all Module 5. Module 6, nice module about conservation of energy. Module 7 is on momentum. So a lot of conservation ideas coming up halfway through the course. That'll get us about halfway through. Okay, so we'll have lots of other things to look forward to later on. Okay, any other questions that we can help address? Just going to go look at the course forum, discussion forum again, see if anybody posted anything there. Okay, nothing there yet. One thing I should also say is that Aaron Oswicki, a physics teacher at Boston Latin School here in Boston, he's the one who really designed Module 1. So that's most of his stuff, and Module 2 mostly comes from me. And so you'll have various instructors in charge of those different modules. So see if you notice any differences as we go from one module to the next. So maybe I'll just pan around the room for you guys so you can see the classroom that we're in. We're in really kind of a fancy classroom here at Boston University. It's our studio classroom. And I'll just do a quick pan. You can see Mark over there. Okay, so there's Mark waving to you. And completely empty right now, but next week the students will all be back here at Boston University, and we'll be doing introductory physics classes in here starting a week from today, in fact. Okay, we're down to two viewers now, Mark, which I think maybe you and me. Oh, three. Somebody just joined us. Welcome. If you have any questions, just let us know. Again, you should see an icon in the top right-hand corner. It looks sort of like 9 buttons, 3x3 array. If you click on that, you can click on Q&A, the question and answer feature, and that will bring up a sidebar on your screen, and you can ask a new question. And so you can feel free to fire in a question. Oh, back to 2 viewers, which I think is just myself and Mark again. So we're scaring everybody away. So if you're just joining us, welcome. So feel free to ask us questions. Mark Riemann and myself are here. Be happy to answer anything you have about Module 1 or any other parts of the course. So if you're wondering how to ask a question, you should see little icon in the top right. It's a 3x3 array of dots. You click on there, you can enable your Q&A, your question and answer feature. That brings up a sidebar. And you can type in a question there, and if you type in your question, we'll be happy to address it here. Just going to scroll back to the discussion forum on the course and just see if anybody has posted anything there. Okay, so no questions there at all. Okay, so some course statistics if you're interested. We've got about 7,500 students signed up for it, of which about 3,000 were active in the first week. So quite a lot of people from, and I think we've got 146 countries around the world represented. So. Again, if you're just joining us, welcome. Feel free to ask us questions. We have about 15 more minutes where we're going to be here answering questions. We answered a few in the first 45 minutes. Again, if you want to know how to enable your Q&A feature, you just look for the set of 9 dots, that icon at the top right corner. You click on that. You can bring up your Q&A feature, and that will open up a sidebar in your window. You can type in a question. Oh, well, here's a question. Let's see what we got here. Okay, so this is more of a puzzle than anything else. You have a bridge. Only 2 people are allowed on the bridge at one time. One can get across in 10 minutes, one in 5 minutes, one in 3 minutes, and one in 1 minute. What is the shortest time to get everyone across? Enjoy. Okay, so I'm going to say 10 minutes. You send the really slow person across first, and then he can go with the 5-minute person. The 5-minute person gets over. 3-minute person goes. The 1-minute person goes. And then the 10-minute person should arrive. That's my answer. 10 minutes to get everybody across. That's if they're all going the same way, isn't it? So, make a difference if they go in other directions? I don't think so. Okay, thanks for that puzzle, Will. You're back? Okay, so we're down to about 11 minutes left to go in our office hours. So, I've got two versions of Mark Greenman actually now. Okay, first one got lost and he's found again. Okay, in addition to two viewers, I think at least one of those viewers is myself on a different computer. So, to anyone else out there, feel free to fire away with any question you'd like. If you're just joining us, welcome. So Mark Greenman and I are here at the Boston University Physics Department, ready to answer your questions for another 10 minutes. If you want to know how to ask a question, you should see a little icon at the top right of your screen. It's a set of 9 dots in a 3x3 array. If you click on that, you can enable your Q&A, question and answer, feature, and that should bring up a sidebar on your window, and you can pose a new question for us. So feel free to write in a question, and we will do our best to answer it. Okay, so welcome to our first AP Physics 1 office hour. So feel free to ask us a question. Again, you can turn on your Q&A feature of your Google Hangout using the little icon that has the 9 dots on it, 3x3 array of 9 dots. Enable your Q&A feature, and you can ask us a new question. Ask us anything. We'll try and answer it. Okay, so we're down to 8 more minutes of office hours. So feel free to fire in your questions if you have any. Again, you should be able to open up a Q&A sidebar on your screen. You can get at that through the icon at the top right, which shows the 9 dots in a 3x3 array. Click on that. Click on your Q&A feature. That'll open up a sidebar, and you'll be able to post a new question. And we will do our best to answer it. It can be about Module 1, it can be about the course, or anything you'd like. Such as, how cold is it today? So here in Boston, it is very cold. So certainly below freezing. So I hope you're warmer wherever you are. Okay, we're down to our last 6 minutes in these action-packed office hours. So feel free to ask us more questions. Anyone who's out there. So you can turn on your question and answer feature using the little icon that's the set of 9 dots, top right of your screen. Type in a question, and we will do our best to answer it. Here's another question from Will. How do you cut a cake in 8 equal pieces with only 3 cuts? Let's see, can we do that? It's a good question. I guess I can do it in 4 cuts, but that's too easy, isn't it? What if you cut it in half and then stack the 2 halves on top of one another? And then you could do another, cut those in half and stack those up, and then do one last cut. I think that's how I do it. I think you got to stack it up. Thanks for feeling bad for us, but we're okay. It's just an experiment. It's the first time we've done it. So next time, I think what we'll try and do is advertise it a little more ahead of time. We've got to figure out when next time is, actually. This week was not much going on here at Boston University. The students aren't coming back till next week, but after that, it gets pretty busy around here. So we'll have to pick our time wisely after this. But we'll figure it out another time. See if we get any more people showing up. And maybe the material will get harder, too, so maybe more people will be here asking questions. Okay, we're down to our last 3 minutes of office hours, our first office hour for the AP Physics 1 class. Official title is Preparing for the AP Physics 1 test, actually, on edX. So, if you have any final questions, this is the time to fire them in. Okay, so we're down to our final minutes of our first office hour here. So, I'd like to thank Mark Greenman for joining us. So,
forward to more students.
That's right. We're looking forward to having more questions that we can handle next time. But maybe the deeper we go into the course, the more questions we'll get on both the module that we're doing at that time as well as any of the earlier modules. The earlier modules are never taken down, so they'll still be active as the course goes through. So you can always go back and review anything from early on. And once again, we'll have Module 2 being released next Tuesday at 2 p.m. Eastern, 1700 hours Universal Time. And until next time, we will say goodbye for now and thank you for joining us. See you next time and bring your friends.